Hello there, Coach Reza. My name is Owen Beatty, student number 101379668, and this will be my video submission for our first assignment in our COMP3132 class, our machine learning. So let me just get right into it. So first of all, my student information, just like always, then my import statements, and the ways that we take the fashion.mnist data. Next, we'll just jump right in with the first requirement, which will just be the dimensions of each set of images and labels. As you can see, we have 60,000 different values, as well as they're 28 by 28 in nature, so 28 pixels by 28 pixels. Then we'll just check the lengths, which we kind of saw in the dimensions. Then I just went ahead and showed the 15 first labels from the training and test label sets. That's number 3. Then we will grab the digital content of the image at index 5. I kind of wish that I either could or knew how to expand this so we could kind of see this, like this set as one entire row of pixels, because that would kind of show us the actual image without showing us the actual image, because we would kind of see where the outline of, I believe it's a sweater, where the outline of the sweater actually is. Either way, we do get to see it right here anyway. It would have just been cool to see it with the pixel values. So here, we'll go ahead and use matplotlib to go ahead and show us the actual image in index 5. We mapped it to gray just so that it wasn't all weird green and purple. So then moving on to 6, we will check the index number 5 from the training labels, and based on this list up here, we will go ahead and pull out that it is a pullover. It is the label for 2, which pullover is number 2. Then numbers 7, 8, and 9 are all the exact same except for the image 500, which is a dress in this case, and we can see in number 9, just like number 6, that we pull number 3, which is a dress, and that's what index number 500 is. So then number 10, we have a few more important statements, the model and layers. The models is for layering the neural networks, and the layers are for different types of layers for the model. And then we will designate the my network as a sequential model, and go ahead and start to reshape and normalize the images that we have. So here we are multiplying, we're flattening it to make the images more usable, and then normalizing them, which is to change the value that we have here and make that once again more easily usable for the neural network. Then number 14, 15, and 16, we will add layers ranging between 512 using ReLU, 128 using ReLU, and then finally our last layer of 10 using softmax. Softmax here is for outputting a probability, so it's more on the output layer rather than ReLU, which is just positive or negative, binary yes or no. And then I've combined steps 17, 18, and 20 because of how it's worded over here. We wanted to use 2 different settings for the compiler, so I've gone ahead and for these 2 cells here, we use the atom, sparse categorical, cross entropy, and accuracy, just like here. And we come out at the end after doing the 10 epochs. We grab the loss val and accuracy values, and we can see that we have a 20% accuracy, or 20% loss value, and 92% accuracy value, which is pretty good. And we'll explain how that's different to the other MNIST set afterwards. And then over here, I could not get my RMS prop to run with just the normal categorical cross entropy. I believe that's due to the shape of the data set that I'm feeding in, but I couldn't figure out what the issue with that was. So everything that I found online just told me that because of, I think, either the flattening or the normalization, we weren't able to use the normal categorical cross entropy and had to use the sparse version for both of them. So once again, I'll just explain the loss value, which we have 22.8%, which is significantly higher on RMS prop than Atom, and 91.8, which is, I wouldn't say significantly lower, but is noticeably lower. The difference here is that Atom uses the processes that RMS prop does, be it this, I believe it's like a square pair value, but Atom uses not only that, but also adds a momentum value to make sure that the change in the parameters doesn't change too much in between different checks and everything, which I believe in the end makes it ultimately more effective, at least in this case. Down here, I'll just explain the difference between the MNIST, the normal one, which that was just hand-drawn numbers, I believe. And the fashion.MNIST, we use that today, which included the sweater and the dress and all the other types of clothes. So that's much more difficult for the computer to kind of understand rather than just simple, like a 5 or a 7, something like that. So yeah, I really enjoyed this first assignment. I'm very interested in machine learning. It's absolutely the course that I can see myself transitioning into a job, much more than pretty much any other class that I've had over the entire program. And just thank you. I'll see you on Tuesday. Have a nice night.